Okay, let's dive into this. Welcome to today's explainer, where we're going to unpack one of the absolute most fascinating tech stories of our lifetime. We're going to look at how Nvidia, a company that literally just wanted to make 3D video game graphics look a little better, accidentally became the undisputed foundational brain of the entire global AI economy. I want to kick things off by reading you this exact quote directly from our source material because, honestly, it just perfectly frames everything we're about to talk about. The story of NVIDIA's dominance is not the story of a company that saw the AI revolution coming. It is the story of a company that built the right tool for the wrong reason, then watched the world reorganize itself around what they had made. Just think about the sheer irony of that for a second. Almost none of NVIDIA's massive world-changing success in AI was originally planned. It was entirely accidental. Now, what's really interesting about this slide is the massive paradox it presents. How exactly did a quest to draw better video game graphics ultimately build the brain of modern AI? It's kind of like the ultimate technological Trojan horse story, right? Well, to really get it, we have to go back to the very beginning, way before anyone was even whispering about neural networks or deep learning. Section 1. The Denny's booth, a modest start in San Jose. Picture this. It's early 1993. 30-year-old Jensen Huang sits down in a Denny's booth with two engineers to solve one decidedly unglamorous problem, making 3D PC graphics look less terrible. They named their little venture Nvidia, after the Latin word for envy. But look, their early years, absolute battlefield. In 1995, their very first chip, the NV1, was a massive flop that came this close to killing the company. They had to go back to the drawing board, barely survived with the Riva 128 in 97, and then in 1999, everything completely shifted with the GeForce 256. Section 2. Inventing the GPU, redefining the math. And this brilliantly illustrates what happened next. When Nvidia launched the GeForce 256, it wasn't just slick marketing. They invented an entirely new hardware category, the graphics processing unit, or GPU. They took all that heavy mathematical lifting of transform and lighting completely off the central processor, the CPU. Think of the CPU like a single, incredibly fast race car, right? It handles one complex route at a time. The GPU, on the other hand, is like a fleet of thousands of delivery minivans. It's built to perform the exact same simple math operation, multiplying numbers, millions of times simultaneously. Perfect for drawing pixels. But for anything else, nobody was even thinking about it yet.
Section 3. The secret weapon, CUDA.
Let's fast forward a bit to 2004. A Stanford doctoral student named Ian Buck was doing something kind of weird. He was using Nvidia graphics cards to run scientific calculations instead of video games. Nvidia actually noticed this, hired him, and by 2007, they released his project to the world as CUDA. You can think of CUDA as the ultimate translator. It completely stripped away the friction of having to pretend you were rendering a 3D scene just to use the chip. It let programmers write standard C code and just blast it across thousands of GPU cores simultaneously. So suddenly, physicists and scientists had access to raw parallel math. And the crazy part? The mainstream press barely batted an eye. Section 4. The deep learning collision. The spark meets the powder keg. Set the scene for a second. It's 2012. Researchers had already built ImageNet, this massive data set of 14 million photos, thanks to Fei-Fei Li. But making sense of all that data required almost impossible computation. Enter Alex Krzyzewski up in Toronto. He was experimenting with deep convolutional neural networks and realized something profound. Training these networks was really just a massive parallel math problem, the exact kind of math GPUs were built for. So, working literally out of his bedroom, Krzyzewski took just two off-the-shelf consumer Nvidia gaming cards he bought at a local store, trained his network for 5 days, and submitted it to the big ImageNet competition. So the crucial point is right here, 15.3%. That was the top 5 error rate of Krzyzewski's AlexNet. To put that into perspective, the second-place entry was stuck way back at 26.2%. This wasn't just some incremental update, it was a total rupture in computer science. The starting gun for the deep learning era had officially fired, and no joke, it ran entirely on consumer gaming hardware. Section 5. Software is the true moat. To their credit, Nvidia instantly recognized the magnitude of this. They realized the most important application of parallel computing wasn't gains anymore, it was intelligence. And they completely reoriented their entire architecture. Look at this progression.
In 2012, chips like Kepler were basically just a raw compute evolution. But by 2017, with the V100, they introduced tensor cores, hardware explicitly designed for AI math. By the time the 2022 H100 arrived with an unbelievable 80 billion transistors, they had totally inverted their business model. It was no longer a gaming chip doing AI on the side. It was an absolute machine learning engine that just happened to also run graphics.
Let's move to and see how this builds into their ultimate defense. You might be wondering, why didn't AMD with ROCm or Intel with OneAPI just build a faster chip to compete? Well, they certainly tried. But NVIDIA's impenetrable moat isn't just hardware. It's this incredibly deep software ecosystem. Over 2 decades, they built an absolute fortress around CUDA. We're talking over 5 million active developers, deeply hand-tuned libraries, and a foundation literally baked into every major AI framework, like PyTorch and TensorFlow. Heck, even decades of Stack Overflow answers. Switching to a competitor doesn't just mean buying a new chip. It means abandoning an entire cultural and technical ecosystem.
Section 6. The Kingmaker Era, Dominating the 2020s. All of this invisible CUDA infrastructure completely set the stage for November 2022. When ChatGPT launched and totally captivated the world, the real behind-the-scenes story was Nvidia. Every single training run, every generated response you see, runs on their hardware. The most visible AI product in human history is fundamentally a CUDA application, and that translates to absolute staggering scale. An estimated 90% or higher share of the global AI training market as of 2026. Of course, absolute dominance brings massive, massive tension. Right now, there are huge forces testing the limits of this monopoly. Neutrally speaking, the market is incredibly delicate right now. On one side, you have the US government actively restricting the export of Nvidia's most advanced chips to China. And on the other side, Nvidia's own biggest cloud partners, the hyperscalers, are desperately trying to build their own custom silicon to escape this dependency. You've got Google with their TPUs, Amazon with Trainium, Microsoft with Maya. Everyone is pouring billions into finding an alternative.
So bringing this all full circle, we can essentially summarize Jensen Huang's 33-year tenure running NVIDIA in these 3 chaotic, unplanned, but wildly successful steps. Step 1, aim to draw video game triangles faster. Step 2, build a parallel math engine ecosystem. Step 3, accidentally become the foundational infrastructure of the entire global AI economy. It's no wonder Jensen Huang now calls them an accelerated computing company. It's a math engine that just happened to get its start in graphics.
I want to leave you with this final, provocative thought. If the foundational infrastructure of the AI revolution was literally just an accidental byproduct of a quest to make better video games, what other world-changing technologies are hiding in plain sight today? What's being built right now for completely different reasons that might reshape our future? It really makes you wonder what the next big accidental empire will be. Thank you so much for joining me for this explainer. Keep asking questions, and I'll catch you next time.